Okay, in this lesson we'll talk about comparing and ordering rational numbers. So here in the first example, I'm given a decimal 4.5 or 4 5/10, or in mixed number form it'd be 4.5. And I'm asked, what is the opposite of this number? Now, if you're asked for the opposite, remember opposite means change the sign. So since this number is positive, well, the opposite of that will be negative. It will be negative 4.5. Let's just use the decimal form, or negative 4.5. If you're asked for the absolute value means the distance from zero. How far is that number away from zero? And remember, absolute value is always positive. So how far is 4.5 away from zero? Well, it is 4.5 away from zero. Now let's graph this number and its opposite. So if the number is 4.5 or 4.5, and here's my number line, here's 5, so it must be going up by 1. This must be 1, 2, 3, 4. And in the other direction, to the left of 0, I have negative 1, negative 2, negative 3, negative 4, negative 5. Okay, so 4.5 would be halfway between 4 and 5, so right there, that's 4.5. And let's also graph the opposite of 4.5. So I go to the left of 0, that's my negatives, and negative 4.5 would be halfway between negative 4 and negative 5. So right there would be negative 4.5. Okay, in this next example, we're going to take a fraction to a decimal. Now, to take a fraction to a decimal, we're basically dividing, because that's what the horizontal fraction bar right here, that horizontal fraction bar can also be read as divided by. So I can read the fraction 1/4 as 1 divided by 4. Now, right here I have the top number should go inside the division bracket. So if the top number is 1, it goes inside the division bracket, and the bottom number 4 goes outside the division bracket. Okay, now I have 1 divided by 4. Can 4 go into 1? No, it goes in 0 times, right? It's too big. It cannot go into 1. Now here I have a note. Add placeholder zeros after the decimal so that you can continue to divide. Now remember, the decimal on 1, if you don't see the decimal is after the last digit that you do see. So the decimal is right here. So I can add placeholder zeros after the decimal. It does not change the value of the number. This number is still 1, but it allows me to continue to divide. Now remember, this decimal goes straight up into your answer, which is called the quotient, right? The answer to a division problem. So it goes straight up into my answer. The decimal is right there. Now, can 4 go into, I'm going to consider the first 2 digits. Can 4 go into 10? Yeah, it goes in twice. So I put a 2. 2 times 4 is 8. Subtract. 10 minus 8 is 2. Just like normal long division, after you subtract, you bring down the next digit, which is the placeholder 0 that you added. Can 4 go into 20? Yep, it goes in 5 times, exactly 5 times, because 5 times 4 is 20. You subtract and get a remainder of 0. Once your remainder is 0, you know you're done dividing, and so we would say this is a terminating decimal. This decimal is terminating because it ends, or it stops, or your remainder is 0. So 1/4 in decimal form is 0.25, 25 hundredths. Now the next example, 2 1/3. Let's also take this to a decimal, and there's a couple of different approaches here. You could say, since this is 2 1/3, it's going to be 2 point something. I just need to figure out what this fraction is in decimal form. Once I know what that fraction is in decimal form, I can just put it right there. Now, if you divide 1 by 3, you'll figure out that it's 0.3 repeating, and so if you have 2 1/3, it would be 2.3 repeating. All right, so that's the first approach. The second approach is to make this mixed number an improper fraction by using the C method, right? 3 times 2 is 6, plus 1 is 7, over the original denominator of 3. And if you have 7 over 3, well, this just means 7 divided by 3. So top number inside, bottom number goes outside. 3 goes into 7 twice. 2 times 3 is 6. I have to add placeholder zeros so that I can continue to divide. 7 minus 6 is 1. Bring down the next digit. The decimal goes straight up into your answer. 3 goes into 10 3 times. 3 times 3 is 9. subtract to get 1, bring down your next digit, and you will see that you will continue to get 3s over and over and over again. So again, this will be 2.3 repeating, with the repeating bar only over the digit 3, since that is the only digit that repeats. All right, so this is a repeating decimal. We had terminating, that's one that stops or ends or terminates. A repeating decimal, a digit or digits, in this case 1 digit, repeats over and over again. All right, so there's fraction to decimal. We can also go the other way. If we have a decimal, we can make it a fraction. In the first example, I have 55 hundredths, and that's how I should read this, because this 5, the first 5 is in the tenths place, and that 5 is in the hundredths place. So I have 55 over 100, which is correct, but let's go ahead and simplify this, put it in simplest form. Since this ends in a 5 and that ends in a 0, I know they're both divisible by 5, so let's divide the top and the bottom by 5, and I would get 11 over 20, 11 twentieths, and that is simplest form. So I went from decimal to a fraction in simplest form. Next I have negative 7.08, or negative 7 and 8 hundredths, right? Because 8 is in the hundredths place. Now, can you simplify the fractional part, 8 over 100? Well, they're both divisible by 2, but they're also divisible by 4. So if I divide the top and the bottom by 4, I would get 2 fiftieths. Now remember, that's just the fractional part. You still have this part, negative 7. So this is negative 7 and this, negative 7 and 2 fiftieths, and we'll go ahead and leave it as a mixed number. Negative 7 and 2 25ths, right? 100 divided by 4 is 25. So negative 7 and 2 25ths. All right, next we're going to compare numbers, and we're going to compare a decimal and a fraction. So basically, since they're in different forms, you need to have them in the same form, and the easiest form to compare is in decimal form. So we're going to compare 2 tenths to 1/4. Is it less than, greater than, or equal to? All right, so let's take this fraction 1/4 to a decimal, and we did that in the previous example, right? We said that 1/4 is the same as 2500, so this is 0.25. All right, now since this has 2 digits after the decimal, let's also write this decimal with 2 digits after it. And 0.2, remember, is the same thing as 0.20, because we can add a placeholder 0. So we're comparing 20 hundredths to 25 hundredths, and since we have more hundredths, right, this one is greater. 25 hundredths is greater than 20 hundredths, so I'm going to put that 20 hundredths is less than 25 hundredths. The second example, we're going to compare negative 7/8 to negative 8/10. So if you take this fraction to a decimal, you will get negative 0.875. Okay, so that's in decimal form. This one is already in decimal form, and if I add placeholder zeros so that I have 3 digits after the decimal, just like this one, I have negative 875 thousandths and negative 800 thousandths if I'm reading this with a thousands place value. Now, the greater one, or since they're both negative, so basically I'm looking for which one is closest to 0, because the one closest to 0 will be further to the right on the number line for negative numbers, and so the one that's greater or furthest to the right on the number line would be this number, negative 8/10. So this number, negative 7/8, is less than negative 8/10. Okay, finally, I'm going to graph these numbers on a number line. Most of these I've already done in the video. So negative 4.5, where is that on the number line? Well, here's the negatives. It's between negative 4 and negative 5. So I'm going to put a dot right here and say that's negative 4.5. Next, I have 1/4, which remember was 0.25. And so that's going to be between 0 and 1. Here's 0, here's 1. And so basically it's 1/4 of the way from 0 to 1. So it's about right there. That's where 1/4 is. Then I have 2 and 1/3. Well, 2 and 1/3 is going to be between 2 and 3. Here are 2 and 3. 2 and 1/3 will be 1/3 of the way from 2 to 3. So that's 2 and 1/3. And then negative 0.8. That's going to be between 0 and negative 1. It's going to be almost to negative 1, but not quite. Okay, so I'm going to call that negative 0.8, and I've graphed those numbers on the number line.